Hello everyone. So today we are going to explore the network communication through the PDU. PDU stands for Protocol Data Unit, or you can say we are going to peep into the data units of each protocol when any communication is made in the network. So we will walk through the entire process using a Cisco packet tracer. So let's start. So in today's exercise, I will be continuing with our previous experiment that we did in this packet tracer. So we have simulated a network environment in which we have created a network in which we try to connect some devices to the server using a router and internet. Already we have gone successfully with this experiment, so you just look to the previous video to check that how all the connection has been made. So in this exercise we are simply trying to peep into the PDU so that we can see that when any communication is made in the network, then how the things are working. So typically we know that in the communication at the sender side and receiver side, there is a layer structure is there, and the packet has to move from layer to layer to reach to the destination. So we'll see that how these layers actually worked in the actual communication. So let's have a very quick look of the packet format. So if you look at the very first figure, this is the header format for the IP. So you can see that we have, this is the kind of 4 bytes for version, header length, service type, total length, and the next row is for the fragmentation. And then we have time delay protocol, header checksum. So in order to understand deeply the entire process, I am assuming that you are well aware about the packet formats of these protocols. And this is for the IP. The next one is for the ICMP, and this is for the ARP. So we know that whenever the communication is made using our network devices, then these protocols actually play a major role to make the entire process possible. So let's move to the Cisco packet tracer. Okay, so we have already set up this network, and quickly we will check that the things are working properly or not. So let us try to connect using this laptop to this server. So in order to do this, we need to send a ping command. Ping command is basically used to check that we are able to reach to the desired destination or not. So we will use this. Now for this we can either write the ping command, or you can also use the web browser, because our server is a DNS server. So we will check with both the ways. So we'll go to the command prompt, and first we will also see that what is the IP given here, because we have used DHCP method to acquire the IP for this machine. So when I say IP config, it will tell you what IP has been assigned to this laptop. So here you can see 192.168.100 IP is assigned, and this router is acting as a gateway. So now I will write ping inha. So the server name is inha.com, and here we can see that we are able to connect to our server. Also we can use this browser because our server is a DNS server, so we have the capability to resolve any domain name. So if I write here http inha.com, so let's see what is happening. So we are able to connect. Okay, so if this inha.com is not able to reach, then we would have get different kind of message that it is not reachable. For example, if I write here xyz.com, and you can see that it is not going to resolve, because already in our experiment we have gave the name inha.com to the server, and also we have set the DNS server that how this name to be resolved by using which IP. Okay, so this is already we have checked. Now to observe the simulation of the communication, we have to go to simulation mode. So if you look at the screen, this is a real time where we have configured our topology. Now you have to go to simulation. So here it will show one window where we can see the entire process. So what is required? We need to send a message from one machine to another machine, and then we want to check that how the things are working, that how the layers are playing role to make the communication possible. So here, this is the PDU, which is actually used for sending a message. So just click on it, and I want to send a message from this PC to the laptop. So when I click on it, this becomes the source machine, and when I click on it, this becomes the destination machine. And now you can observe the process of delivering the message. So here you can see how the entire process can be viewed. Also, if you want to focus on only ICMP or ARP protocol, you can just remove all this, and you can just select what other protocols you want to see. So let's say this first, if you want to start the process, you just delete this process, and you can go to edit, and then you can select that you are looking for the ARP and ICMP. So you can see here that it will show you the ARP and ICMP. Let us start the process once again. We will select this PDU. Now I want to send a message from this PC to the tablet. So I'll click here. So my source is a PC and my destination is a tablet. So here you can see that how the things are working. So we keep on pressing this play button. So just to see the next stages. Okay, so this is how the communication has been worked. Now let us peep into the entire process. So when you click here, you can see this is your desktop, the PC machine where you have started the process. So when you click here, it will show you this PDU information, and this is the OSI structure where you can see all the 7 layers are visible to us, and we can just have a look at how the 7 layers are actually working in this communication. So when you send a message from the desktop to the tablet, so actually when you are sending a PDU, one message to other machine, actually you want to send a connection request, and for the connection request actually we are doing a ping command. So here you can see that how things are working. At the layer 3, we are actually generating a ping command. The ping command is basically an ICMP utility. So you see here the ping process start the ping request. So in the ICMP we are using so ICMP is basically used for the error reporting and the query messaging, and this ping is basically a part of query messaging where echo request is being sent to the destination and we get a echo reply. So the ping process is being requested. The ping process basically creates the ICMP echo request message and will send to the lower process. Lower process means it will then deliver to the next layer. The source IP address is not specified. The device set it to the port IP address. So now when the ICMP packet to be created in the ICMP packet, you need to write the sender address and the receiver address. So you can see here the source IP address has been identified, and the source IP address is 192.168.0.101, which is the IP of the PC, and the destination which we have set in our example is this tablet, and the address is 192.168.0.101. .0.1.0.2, and this is the type 8, which is a query message. So it will set the TTL, and then it will the destination IP address is in the same subnet. The device sets the next hop to the destination. So because both the addresses are a part of the same network, so it has been identified, and then the next hop address can be easily determined. Now here you can see the next part is to determine the next hop address. For this, the ARP packet is to be generated, because you know whenever a packet to be delivered, we need to know the MAC address of the destination machine. So here, with the help of ARP packet, we are going to determine this. Also, we can have a look on this PDU details, that how the packet will look like. So here you can see this IP packet has been created. Here you can see this is the version number is 4, and this is all about the information, like this is the header length, and then you can see this is a protocol. Protocol is 1 here. Now protocol 1 means we have sending this IP packet for the ICMP communication. Keep in mind that whenever the IP packet is delivered, it is delivered for the TCP or UDP or the ICMP. Okay, so here this 1 stands for the ICMP. So here you can see that this is being delivered for the ICMP. And then you can see the source IP address is 101, and we want to deliver it to 102. Similarly, you can just have a look for the ICMP structure. This is ICMP, where this is a type 8 because it's a query message, then ID and the sequence number. So all the information can be gathered using here. Similarly, we can close this, and you can go to the ARP. Now here you can see ARP basically worked at the data link layer. So in this entire process, with the help of ARP, we gather the MAC address, and that MAC address is transferred to the layer 2. So in the layer 2, the MAC address has been determined and has been passed. So what is actually happening here? The ARP process construct a request for the target IP address. So with the help of the target IP address, the packet has been sent and over the network, and with the help of that, the ARP of the next host has been determined. The device encapsulates the PDU into the Ethernet frame. Okay, so you can look here. See, again, we can have information about the ARP. Now, because we are talking about the ARP, so the ARP information has been shown here. So it actually tells that what is the size of your MAC address, and then what is the header length, and all of the information is already been shown here. So here you can see that when the packet has been forwarded, it has forwarded from at a desktop. Here the ICMP packet has been prepared, and then it also makes an ARP request. Then ARP request is sent from desktop to home network. And in order to gather the ARP, it has sending the request to the laptop as well as to the tablet, because this is in the same network. It has already been determined with the destination that the destination address is in the same network. So to generate the ARP request, after reaching the request here, it will send a message to this machine and this machine to ask that I am looking for the destination MAC address, kindly revert back. So you can see that when actually it goes there, it has been cancelled because the destination address is not a laptop. If you have observed here, it shows the red cross while sending this message, but when it goes there, it shows a green tick mark. That means this machine has accepted the ARP request and then replied back. So you can see that it sends to the home network to laptop, and then home network got the message from the tablet, and then home network is sending the request to tablet, and then home network actually get the MAC address, and then this MAC address to be informed to the desktop. Then this desktop is now sending a packet, and then it is delivered with the ICMP. So the entire communication is visible here. Now let us try with another communication and see how the things are working. Let us delete this. So now we want to see that how the transmission is done from PC to the server. So again we will select this and go to PC here. This is a source and then this is our destination, and the process will start. And now you will observe one difference here. Now you can see that now there is no ARP packet has been shown here. Okay, it goes to this, and then it will be replied back. So actually this is the ping command is actually executed here. When I am doing this PDU request, it is nothing but a ping command where a message is sent from the desktop to server, and then server is actually replying with the echo reply message. But we can't see any ARP here. The reason being the ARP is not visible here because before demonstrating this, I have already just sent one packet from the desktop to the server, and while doing this already that ARP packet has been sent earlier. What I mean to say is, once you send a packet from one source to any destination, so initially the first time when you are sending, the router is not aware about the MAC address of the next host to which the packet will be forwarded, so it will take help of the ARP. But the next time when you send the packet to the same machine, then router already have the information and there is no need to gather the MAC address of the host machine in order to forward the packet. So here you can see already the router has the information the MAC address of the next host, so the ARP has not used here, and simply the ICMP packet has been used for the entire communication. This is something like, if you have realized, whenever you want to connect to any server, so you write its domain name. For example, if you want to connect to google.com, so the very first time when you write on the browser google.com, it may take some time because it goes to the DNS server which will resolve this name to the actual IP. But the next time when you again use google.com, you are able to connect at a faster. The reason being because the very first time when you connect to the google.com server, DNS server is being used to resolve the IP. But the next time when the same google.com has been used, then already the router maintains this information in the local cache that will be used to deliver the packet. So ARP is only used when the router has no information that how the packet to be forwarded, and the router needs to know the MAC address of the next host. So just have a look here if you want to see that about the information. Now this is now here we can just have a look about the inbound layers and outbound layers. So inbound basically refer when we are going to see the packet, and outbound is a scenario when the packet has been released from a device. So initially when the packet is delivered from the source machine, we have to check for the outbound. So for example, if we look here, you can see here that we have inbound and outbound. So if you go at the very beginning, this is our starting. So here you can see that there is no inbound because we are releasing the packet from the source, from the sender machine, and there is no receiver, and the sender machine is not receiving any packet. So we have only the outbound is actually shown here. So this is the OSI format visible to us, and you can see the entire process, that how the things are working. And this is the outbound PDU details, that how the packet has been prepared and delivered during this transmission. One more thing, as I said that when you use the PDU, we are actually sending a ping command, and ping command is basically ICMP utility. So we can also demonstrate the entire process by running the ping command. For example, if I want to send any message from this laptop to the server using ping command, then also we can have a look on this kind of simulation panel. We can have a look at how the packet moves. So let us delete this, and we'll go to laptop, we'll go to the command prompt, and here let us write here ping inha.com. That means we want to connect to our server, and here you can see that how the process is now working. So you can see here that we can also simulate this transmission using this command prompt window. So this is all for this discussion, and I hope that you have understood that how the transmissions actually works in the network, and how these layers actually play a role to make this communication possible. And you can even peep to each protocol, that how these protocols plays an important role, and the header format that we have studied theoretically, we can also now have a chance to peep into that how the packets have been formed. So this is all for this simulation, and we will see more about a packet tracer in our next video. Thank you very much.